I welcome you all to today's lesson. We continue from where we ended. So if you remember very well, this was the question, this was time given. So this is the question that I gave you. So I want us to answer this question together. And like I told you, I want to see all the notes that I've been giving. I always tell you to write the notes. So I want everyone to capture the notes and send to me on WhatsApp. I want to see how serious we are and the work that we've covered so far. So like I told you, this is not punishment, but I want to make sure that we all move at the same page, and I don't want to leave anyone behind. So simple instructions. I want to see all the notes that I've given so far and the book that you're using. These are online tuitions, and it's very difficult for me to see your book physically, but it's easy for you to capture and send to me the notes that we've covered. So you capture the same way you get to capture whenever you are submitting. So this is physics. The moment we are done with this, then you capture the notes. I see how serious we are and the notes that we've covered so far, plus the work that we are going to do today. So this was the question that I gave you. Then we ended on moment. This is our current topic. So I'm going to try by all means to finish this topic, which is moment. So let us answer this question. Then we go to our actual topic. It's good that we've revised through certain topics that we covered some time back. So those of you that missed out certain things that we covered some time back, I believe you've tried to catch up here and there. I've forwarded you some lessons, so just need to follow me properly. So even as we are doing moment, I'll try to go through a lot of questions under moment so that we try to understand this topic. We get the basics. So this is what I want you to do. So even as we get to do this, let us move together. Follow me properly even as I get to teach you. So the question was saying it takes 2.05 seconds to move from A to B, C, then back to B. So this thing will move from, so this bulb, this is a bulb, will move from A to C and back to B. And the time it is going to take, the time will be 2.05. So what you need to know is the formula. You need to know the formula. What is the formula? So the formula that let me try to change the marker. So the formula that we get to use, period is equal to time over n. What is n here? N is the number of oscillation. That is n. T here is the time taken. So this was the first question. I believe the first question was telling you to calculate the period. Then the second question was telling you to find the frequency. So what you say is this is equal to now. What is the time? That is the time 2.05 over the number of oscillation. How do we find the number of oscillation? I told you that from here to there, that is 1 over 2. So if it moved from A to B, you just need to get that one. Then from B to C, from A to C, it is what? 2 over 4. Then from here to there, this is 3 over 4. Have you seen? So if it was just telling you that from A to B, just need to get this one. If it was telling you from A to C, you just need to get this one. If it is telling you to A, C, then back to B, we need to get this one. So what is the question saying? The question is saying it moved from A to C and back to B. So we get this one, which is what? 3 over 4. So 3 over 4. The 3 over 4 is now equal to what? 0.75. So this is 3 over 4. 0.75. This is the one that you're going to write here, 0.75. So therefore, the period is now equal to, so if you try to divide here, what answer are you getting whenever you divide? So you divide here, you write your answer. So I believe we've got calculators. No one can fail to divide here. When you divide there, you write your answer. So this is your work. I want you to participate in everything that we are doing. So divide here, then you write your answer in what? Seconds. Don't forget to put units. The units are what? Seconds. So you say seconds. After you write the answer, you put seconds like this. You are done. So after you do this, then you make sure that you put your answer to 2 decimal places. So if it gives you 0.867, 2 decimal places, how do we change to 2 decimal places? From here, from this point 1, 2. So the boundary here. Is this number greater than 5 or less than 5? It is greater than 5. So you put a 1 here. So this one automatically becomes 0.8, then a 7 here. So this is the answer like that. So in this case, if you divide here, the answer that you're going to get, hope this is the answer that you wrote, 7.3 seconds like this. So this is the what? The period. This is how you calculate the period. So once you divide, this is the answer that you get. Then the other question, which was B, what was B telling you? So question B was telling you to find the frequency. Frequency is equal to what? Frequency is equal to 1 over period. This is the formula for frequency. You say frequency is equal to 1 over, what is your period? What is your period? This is the period which is here, which is 2.73. So the same thing here, divide there. So when you divide, what answer are you getting when you divide here? Get your answer 0.366 like that. Have you seen? So 2 decimal places, how do you convert to 2 decimal places? This is the same as what? From here to 1, 2. So the boundary line is here. I've just forgotten to put these numbers deliberately. The main interest is between these. So this is greater than 5. You put a 1 there. This one becomes 7. So it's 0.3. This one becomes 7. So 7. Then the units has for frequency. So these units are very important in physics. I always tell you this. Whenever you are dealing with any question in physics, you don't need to forget the units. So units are very important in physics. So I want you people to get this, and I want you to understand everything that I'm illustrating here. So this is the question that I gave you. This is the question that we answered. So if you answered, well and good. If you didn't answer, these are the corrections that you need to put. So we now go back to our actual topic that we are doing. So we go back to our actual topic. What are we looking at? We are looking at moment. So moment, we are looking at moment. And tonight, we need to make sure that we conclude moment. So what are we looking at? We are looking at moment. So I told you the definition of moment. You are able to define moment. So just want us to conclude this topic called moment today. So this, like when you're given a question, let's say I'll start with this. So these, I gave you some of these questions in your exercise. So we are also revising through those questions that I gave you. So you are given something like this. This is what you are given like this. This is here. It is like this there. So this is a pivot, you know. Then we've got this is a perpendicular distance. Like this, it is like this. Then here, what are you given? You are given the force, which is 0.5 newtons. Then a perpendicular distance. We've got a distance here, which is perpendicular. A distance of what? A distance of 2 meters, like this. This is what you're given. So in this case, you know that here, this is a pivot. Then you are taught to calculate the moment. You know that moment is the turning effect of a force about a pivot. So what we get to do is that you say moment is equal to force times distance. This distance should be perpendicular. So I believe this is the exercise that I gave you. So moment is equal to, what is your force there? The force is given 0.5 times. So we'll be answering these things together. I want you to participate. So I won't be writing final answers deliberately. I want you to participate and I want you to be involved in everything that we are doing. So here, this is in meters already. So no need of changing like this, times 2, which is equal to. So after you calculate here, multiply here, what answer you getting? You put not co like this. You put, this is Newton's meter. These are the units like this. So the answer, put it here, then put this. So this is how you need to answer the first question. This is how you needed to answer. So if you didn't answer, make sure that you make those corrections. So this is how we needed to answer that question. I want you to understand moment at a certain level where you won't fail any question in an exam. So this is what you need to follow. These are procedures that you need to do. Let us move to the next question. Write the final answer here. 0.5 times 2. You need to have a calculator. Don't use a calculator on the phone. You use a scientific calculator. Make sure you've bought yourself a calculator that you'll be using till you write your exams. So you buy yourself a nice calculator. So we move to the other question. So all these are the questions from the exercise. I remember giving you this question. Then we've got a force that was like this. Then 10 newtons like this. We had a perpendicular distance here like this. This was a perpendicular distance like this. This was 5 meters like this. The question was telling us to find the moment. How can you find the moment? Is it possible to find the moment here? No, the answer is what? 0 moment. Like this. This is the answer. Why? Because the force and the distance are parallel. So the moment, force and distance are parallel, there is no moment. You cannot calculate the moment. Some of you made mistakes where we are now multiplying that. You even write the formula. Force is moment is equal to force times perpendicular distance. You put your 10 there, you put your 5 there, then you say 50 like this. No, this is not correct. So once you start doing this, I will know that you haven't understood this topic. So make sure you understand this. You get all the necessary concept. You get everything that I'm illustrating here. So we all get to understand this. We get the principles that should be put into consideration. So in this case, the moment, whenever you just see the force, this is the force, and this is the distance. The arrow, have you seen the arrow is like this, and this arrow is like this, meaning they are parallel. And if they are parallel, force and distance are parallel, which means there is no moment, 0 moment, no need of calculating. So these are questions that will be coming in an exam just to test your mind. So such questions will be coming in an exam to test your mind. So this is how you need to understand this. So make sure you are writing down all these things. The question, we've got a key question here. All these questions that I'm answering, they are coming from this one here, which is saying calculate. We are calculating what? Calculate the moment. Calculate the moment in the following. In the following. So this is where all the questions I'm answering are coming from. So the question is calculate the moment in the following. We are just calculating moment, calculating moment. This is what we are doing. We are just calculating moment, moment, moment. So we move to the next question. We move to the next question. So the next question that we are going to do is like this. So I want to change the way that you get to view questions, the way you get to handle them, or the way you get to see them. So this is how this question is like this. So we've got a distance from here to there. This distance is given. So we are given that distance like this. Have you seen? This is what we are given. we are given 5 meters. This is 5 meters. The good part is that no need of converting because they are given in meters. But when distance is given in centimeters, you need to convert that. Then we also this is a pivot. A pivot is here. This is a pivot. This is a pivot like this. So we've got a distance from here to there. This distance here, we are given that distance. The distance is 2 meters. So this 2 meters, this is the distance, 2 meters. This 2 meters is balanced by a force which is here. The force is 3 newtons. Then we also have, so in this question, have you seen the way this question is? So in this question, we also have a force from here to there. We also have a force that is balancing these two. So how can we calculate now the moment? So we also have, let me just say, let me put a force here. So let's say we have a force that is, let me just say 3, let me use another. So let me just say this is a distance. I've got a force here. So I'll say a force which is here, that is like this, that one, for that one. I'll just say this is, okay, let me just say 6 meters, like this. This is what we are given. So this is what we are given. So now, how can we find the force? How can we find the moment? How can we find the moment? So what I'm going to do in this case, okay, let me remove this. Let me change a question a bit. The question is just like this. Let me say the question is just like this. This is how the question is. The question is just like this. How can we find the moment in this case? How can we find the actual moment? How can we find the moment in this case? So what we need to know is that we have these things which are together, that are in the same position like this. So the way in which we are going to find the moment in this question, we know that what we need to do is that we know that moment is equal to force times distance, like this. Moment is equal to force times distance. So you ask yourself, do you have the distance? The distance, yes, it is given. This is the distance. Have you seen the distance? This is the distance. Do you have the force? No, we don't have any force. But what we know is that from here to there, we've got this force which is here. But we don't have a force from here to there. So what do we need for us to calculate that force? So you know that from here to there, you know that you multiply this, then this one you multiply it by x, which you don't know. So you first calculate that. So that 5 times x, you are going to have 5x, which is equal to, you multiply these two. If you multiply these two, what answer are you getting? You are going to get a what? A 6. So you divide both sides by 5, you also divide there by 5. This cancelled. X is now equal to, so your x will be now equal to what? So your x will now be equal to what? So divide here. When you divide here, so like I told you, I want us to be revising through these questions together. So I want you to participate even as we are answering this. You need to participate in this. So make sure that you participate in this. So when you divide here, what answer are you getting here? What answer are you getting? This into that 1.1. 1 remainder 1. So 1 remainder, we put a 1 there, put a 0 there. 5 into 10, it is 2. So we are getting what? We are getting 1.2. So meaning the 1.2 newtons is here. 1.2 newtons is the one which is here. So moment, you just say now, moment is equal to force 1.2 newtons like this times the distance. What is the distance? What is the distance? The distance here, this is 5 like that, which is equal to So when you multiply here, you discover that you're going to have, if you multiply here, what answer are you getting? The answer that you're getting, then you just say newtons meters, like that. You just do that. So the answer that you're getting, the answer that you're going to get there, which is a 6, isn't it? When you multiply here, you get a 6. So just a 6, this by that. So that is your answer. That is the moment that you are able to see in this. So that's how you need to answer that. We move to the other question. So these are simple questions that I want to devise with you. We've got something like this. This is what you are given. You are given this. You've got a force that is going that side. We also have a force that side. Then we've got something that is balancing these two. So we've got a distance here. We also have a distance this other side, like this. This is what we are given. So we are given, this is 6 meters. This is 2 meters. Then we've got a force here, which is 3 newtons. Then the question is saying, we calculate. So here, these questions that we'll be solving, these all questions that we'll be solving, let me change the question. So we've gone to question 2. So over on our examples, we've gone to question 2. So the question is saying, find the force F. This is the question, so we find force F. So find force F if it is in equilibrium, like this. So equilibrium, EQUILI, like this, equilibrium. So find the force F. So in this case, our force F is here. So this is the question which you are given. This is A. I'll name this as A, like this. I'll call this as A. So you want to find the force F. The force F is here. This is the force F. This is the force F which we are given. So how can you find the force F? You use the formula for principle of moment. So each time you get to see such a question in an exam, the first thing that should come to your mind is the principle of moment. The principle of moment, which states that moment in the clockwise direction is equal to moment in the anti-clockwise direction. Which means that what you are going to do is that you are going to say that F1 D1 is equal to F2 D2. This is what you are going to do. Then these things are already changed for you, so no need of changing them. They are already in meters. But if it was given in centimeters, you need to change this. So you are practicing this, and I won't be writing everything. I want you to finish. I want you to be finishing. So you say force 1, if you want, you can say this is force 1, like just like that. So you can say F1 D1, F2 D2. You will still get the answer. So let's say this is F1. So I'll say F1 times, what is distance? 1, 2, which is equal to force 2, 3 times distance 2, 6, like that. So here you're going to get 2 F1 is equal to 18. Have you seen 18? You say over 2 over 2. So meaning F1 is equal to, what is 18 divided by 2? Have you seen the same way I'm answering this? This is the way in which you are supposed to answer. So 18 divided by 2. What is 18 divided by 2? 18 divided by 2. That is a 9. So 9 what? Force. Newtons. This is F. So F is the force. Here you are told to find the force which is there. So that is what? 9 newtons. So that is 9 what? 9 newtons. That's how we calculate F. You just say, therefore, F is 9 newtons. You are done with that. So that was A. This is how you need to answer. This is how you need to calculate that. So hope you have seen how I'm answering this. If you are making simple mistakes, let's make sure that we handle with those mistakes even as we get to look at other things. So make sure you get this, you understand the principle on this. These are simple stuffs that I believe you can't fail to answer. So after this, I'll just give you one exam question that I want you to answer, that I want you to practice through. So we move to the next question. We move to the next question. We move to the next question. So this is our B. So we move to the next question. The next question is like this. You're given something like this. Let me do this. This is what you're given. Like this. You're given something like this. So this is where it is. We've got this one like that. We've got a force which is here. What is the force there? We don't know. This is the one we want to calculate. But the distance from here to there, it is known. This distance is known. This distance is known. This is 3 meters, like this. Then from here to there, like the distance which is the force 2 newtons known. Then from here to there, we also have this smaller one here, which is 3 newtons. So this is what we are given. This is what we are given. From here to there, this is given also, which is 1 meter. So this is 1 meter. Then this is being cut like this. This is being cut, moves like this. So from here to there, we are given that as 3 meters. This is how the question is. Our key interest is to find F, the force. Then we look at this. Everything is being balanced by this. So we call this as a pivot. This is where the center is. If you've gone to a park, we've got something like this, where a person sits this side and the person sits this other side. They're able to move like this. If this one, there's one on top. Hope we are able to picture that thing. So this thing, the way it is that we know that the moment which is here, from this thing here to this thing going this side, should be equal to everything which is there. So what we are going to do is that we want to calculate, you say this is what? F1 D1. F1 D1 is equal to, so here we've got, have you seen we've got force that is appearing 2 times. So you can say this is F2 D2. You say plus F2 D2. This is what you are going to do. Such that this one is for this one. This one which is here is for that one. But here we only have one thing. From here to there, we only have one force there. It's the same one that we want to calculate. So what you are going to do, you've got this question. This is the question you are given. And what do you want to find? You want to find the force which is here. So the force which is here, you say the force there times distance. What is the distance? The distance is 3. So I'll say 3, which is equal to, I move to this one which is here. So we move to this. What is the force there? The force 3. So 3 times the distance for this one. Have you seen this one is for that one? So you cannot get this one and pick that one. No. This short one is equal to this one. Have you seen? This short one will go with this one. So this short one will go with this one. This longer one will go with this one. Have you seen? Like this. You cannot get this one and that one. No. This one, have you seen from here? Like this. This one moves from here. It is there like that. So times what? 1. Then you say plus. Plus what? Force 2. 2 times distance 2. That one now, which is a 3 like that. This is what you are going to do. So this part which is here, this part will give you 3f, which is equal to, so 3f is equal to, this is 3 plus, this is 6. Have you seen like that? When you do your calculations there, so when you do your calculation, this is 3f is equal to 9 over 3 over 3, such that your F is now equal to 3 newtons. You are done. This is how you need to deal with that. Hope you are able to follow this. Hope you are able to understand all these things that I'm doing. So let's make sure let's make sure we understand these questions. So let's get to see this. Let's make sure we understand everything that I'm doing here. So these are simple things that I want you to get. These are simple things that I want you to understand. So let's just answer one more last question. Then I give you an exercise. I see how we are going to handle it. I see how we are going to answer it. So just a simple one. Hope you've seen how I was answering this. So a simple one. Just a simple example. Simple example. So in this question, the question is saying you find, so the question is saying find the distance. Find the distance D if it is balanced. So when it is balanced like this, find the distance D when it is balanced. So we've got this thing here like this. This is what you're given like this. Then you've got here like this 4 newtons. Even here like this, we've got 2 newtons. Pivot there that is balancing. So from there like this, there to there, these are simple things. I believe you can do this like this. So this is a demarcation telling me the distance from here to there, it is a D, you don't know. From here to there, that is 4 meters. This is a simple question. How can you calculate a D which is there? How can you calculate a D? How can we calculate the D? So the way in which we are going to calculate the D is that this is how we are going to calculate the D. So I want you to follow me properly and follow me clearly. The way in which you are going to calculate the D, you just need to write the formula. I think this one is very simple. You say F1 D1 is equal to F2 D2 like this. F1, that is a 4, times D, that's the distance you want to find, which is equal to, what is the force there? What is the force? 2 times like this 4. The 4 which is there, these are moving in pair like this. They are together like that. So this is 4D is equal to what? 4D is equal to what? 8 over 4. Divide both sides by 4 over 4. So 4 cancelled. You remain with a D. D is equal to what? What is 8 divided by 4? That is a 2. So it means that your distance is what? 2. Is this correct? No. What is missing? Units. Very important. So in everything you are doing, consider the units. You need to make sure that you consider the units. You write appropriate units. So this is what you need to know. Make sure you understand this. You get the important concept on this. So I want you to understand this and I want you to get this. So let's make sure that we understand this clearly. So we are just building up from where we ended. The reason why I've given you a lot of examples is so that you understand, you try and understand this. So don't forget, you share the notes that I've given you so far. From the time that you started on WhatsApp, forward them to me on WhatsApp. So I just want to have a look at them. I see how serious you are. I see if you do write the notes. So make sure you forward me the notes. Like I told you, we are not supposed to write on a paper. Everything should be written in an exercise book. I told you everyone should buy books. By now, I believe we've bought books. So let's see how serious we are. So show me the notes on WhatsApp. Don't say I have other notes. Me, I study just using the same videos. No, you need to have your book, a separate book that you'll be using under my teachings. So like I've been telling you, with me, you don't need physical tuitions. This data that I'm giving you is enough. Make sure you create time, you go through this, you understand all these teachings. You are going to tell me by the end of the day, physics or science will become a simple subject to you. You just need to make sure that you follow everything that I get to say. So when I tell you do this, you do that. When I tell you do this, you just begin to follow everything that I tell you. But if you try to put in your own things, you discover that like you try to do other things that I'm not telling you, then like that you won't progress. So make sure you follow what I'm telling you, everything that I'm telling you. So we conclude with this example. This is your exercise. I want you to answer this same question. So I'll say exercise. I just put exercise. You write in your book exercise, then you copy this question. So the same question, this is the same question. So it is like this. This is how the question is, like this. So balanced on this, like this. So we have a force here, which is 6 newtons. We also have a distance from there to there, the distance which is a d. So from there, like this, we've got it from there. This is, we've got 2 newtons. So from there, that one there, we've got 3 newtons, like that. Then from here, we've got something from here to there. We have 3 newtons. This distance, which is there, the distance that is there, that is 1 meter, like this. This is what I want you to do. So just to change figures, let me try to change the question. Let me try to change the question here. Let me put 8 meters there. Let me put, I'll just say 4 meters, like this. This is how it is. So the question is find the D, which is here. So I've taught you these things and I believe you cannot fail. So let's see how we are going to answer this. Let's see if we've understood the topic, or rather the concept under this. So I'll try to give you a lot of questions under moment. So let me see how you are going to answer this. Let me see how you are going to handle this one. Thank you so much. I'm waiting for the exercise. So I've been telling you, don't share this video. So even each and every lesson, so keep this in your mind. Whether I've told you to share or not to share, make sure you don't share these lessons to any person that is not under my teachings. So this should just be our discipline. We don't need to share. Thank you.